Welcome to Metrology lecture series. In the present video, we will discuss the measurement of runout for gear. Let's see the measurement of gear elements. In industries, different methods are used to inspect gears and check their quality. The method chosen depends on several factors such as how accurate the gear needs to be checked, the size of the gear, the number of gears being produced, the equipment available and cost of the inspection. When a large number of gears are manufactured, then statistical quality control methods are commonly used instead of checking every single gear. For detailed inspection, the following important gear elements are checked. First element is the runout. It checks if the gear rotates properly without wobbling. Second element is the pitch. It checks the spacing between the teeth. So third element is the profile. It checks the shape of the gear teeth. Fourth element is the lead. It checks the alignment of teeth along the gear face. Next element is the backlash. It checks the gap between the mating gear teeth. And last element is the tooth thickness. It checks the how thickness of the each teeth is having. Next we will discuss the measurement of runout. Runout occurs when a gear does not rotate perfectly about its axis. This means the gear is slightly eccentric or not perfectly round. In the schematic you have to observe here pinion shaft is affected by eccentricity, which means here this axis is shifted from its center. Then pinion is not rotate perfectly about its axis, so it will be slightly make an eccentric. So this eccentric we are calling as the amount of runout, and this is the runout effect of the gears. In the simple words, runout is the wobbling of a gear during rotation. So why these runout will be happens mean? So this happens due to out of round of the gear shape, improper mounting or misalignment. So this runout will be occur. So when the gear shape is not perfectly exactly round, it may be shape it will be changes, or maybe improper mounting or maybe misalignment. So due to these two regions, runout will be occur. So let's see what is the runout tolerance. So runout tolerance is the maximum allowed amount of runout for a gear to function properly. Next we will discuss the measurement of runout. In general, gear runout are measured using the single probe method. So this is the schematic representation of the single probe method, and let's see the procedure to determine the gear runout measuring using single probe method. First we have to see the construction and main parts of the setup of this single probe method. So in the schematic you have to observe. So in this method it is consisting of the gear which is has to be measure the runout, and it is the mounted on a shaft. So here we have to observe we are holding this gear with the help of the mandrel or maybe the shaft, and this gear has to be the rotate during the measurement. And next one is it is consisting of the dial indicator or the dial gauge. It is the circular instrument with a pointer, and it has to be measure the small variations in the movements of the gear. And next one is the probe. So this is the probe or the tip. So this is the probe. So runout probe. The probe contact with the flanks of adjacent teeth in the area of the pitch circle. So here you have to observe. So this probe is contacting with the flanks of adjacent teeth in the area of the pitch circle. So in the pitch circle area it is contacting. And probe detects the deviations while rotating of the gear. And next part is the supports or maybe the beam centers. So these are the hold the gear accurately in positions and ensures the proper rotation. So this is the construction and setup of the single probe method. So next we have to see the working procedure. So first we have to place the probe against the gear tooth. So first we have to place this probe against the gear teeth, and we have to rotate the gear slowly. Then after that one we have to rotate the gear. If the gear is perfectly eccentric, then there is no change in reading. If the gear is eccentric, then dial needle has to be moved. So the measurement is taken perpendicular to the gear surface. One more important while measuring. So measurement is taken perpendicular to the gear surface. And the key points you have to remember here. So in this method we are using the only one probe, and probe is contact made at the pitch circle, and this method is very simple and commonly used method, and the reading gives the total runout directly. So in this method, so runout value is giving directly. So the maximum variation in the dial reading is the runout of the gear. So runout equal to the eccentricity of pitch circle, and runout value equal to the 2 into eccentricity. So next we have to discuss about the gear runout measurement using two probe method. So it is the another method is the two probe method. In this case, two probes are using, one is the one probe is fixed, another probe is movable. So in the schematic you have to observe here. So here we are using the two probes. So one probe is the fixed one. So this is the fixed probe. So another one is the movable. So these probes are placed on opposite sides of the gear and touch the same part of the tooth profile. So both have to be touched at the same part of the tooth profile. When the gear is rotated, the two probe method shows readings that are twice those of the single probe method. So I have to remember this one. In the single probe, it is having the only one contact point. In the two probe method, it is having the two contacts which are having the opposite sides, and reading point of view in the 2-point reading equal to the 2 into single probe reading. So this is the discussion regarding the measurement of runout, and thank you.